In 1913, Niels Bohr proposed atomic model of atom. His model was based on the atomic spectra of hydrogen. He retained the basic concept of Rutherford. He applied Planck's quantum theory on revolving electron. Bohr's postulates: 1. Orbit or energy level. 2. Size of orbit. 3. Stationary orbit. 4. Quantized orbit. 5. Energy change of electron. 6. Radius of orbit. 1. Orbit or energy level. The electron revolves around the nucleus in a certain fixed, discrete closed path called orbit or energy level or shell. Electron revolves around the nucleus with high velocity. 2. Size of orbit. Each orbit is associated with a definite amount of energy. These orbits are numbered as n is equal to 1, 2, 3, 4, etc. and according to letter method, they are represented as K, L, M, N, etc. As the value of n increases, the size and energy of orbit also increases. 3. Stationary orbit. As long as electron moves in a particular orbit, its energy is constant, that is, it does not emit or absorb any electromagnetic radiations. So, these are called stationary orbits. 4. Quantized orbit. Electron revolves around the nucleus only in a quantized orbit, that is, the angular momentum of electron is integral multiple of h by 2 pi. mvr is equal to nh by 2 pi, where m is equal to mass of electron, v is equal to velocity of electron, r is equal to radius of orbit, n is equal to number of orbits, that is equal to 1, 2, 3, 4, etc. h is equal to Planck's constant, that is equal to 6.625 into 10 to the power of minus 34 joules per second. 5. Energy change of electron. Energy is emitted when an electron jumps from an outer orbit into an inner orbit. Energy is absorbed when an electron jumps from an inner orbit to an outer orbit. The emission or absorption takes place in quanta. Delta E is equal to h nu, equation 1. The energy of radiation emitted or absorbed is equal to the difference in energies of the two orbits. Delta E is equal to E2 minus E1, equation 2, where E1, E2 are energies of two orbits. From equation 1 and 2, delta E is equal to E2 minus E1, that is equal to h nu. 6. Radius of orbit. He derived an equation for the radius of orbit. R is equal to n square h square by 4 pi square z e square m, where n is equal to number of orbits 1, 2, 3, 4, etc. h is equal to Planck's constant. Z is equal to atomic number. M is equal to mass of electron. E is equal to charge of electron. For hydrogen atom, Z is equal to 1. Rn is equal to 0.529 into 10 to the power of minus 8 n square centimeter, where Rn is radius